Okay, let's do a tutorial on precipitation reactions. When you have precipitation reactions, they're also called a different kind of reaction. They're called a double displacement reaction. It's literally going to be a kind of ionic reaction in which the ions in solution are going to actually come together in particular combinations that are insoluble in solution, so they'll come out as a solid. In this particular equation here we have sodium hydroxide. You add it to magnesium chloride, and they're both aqueous, so they're both dissolved in water. That's what the aqueous means. We need to find out what is actually produced and how much of it is produced. Now, what you should already have for our year 11s and 12s, you should have this waste chemistry data sheet for this is the 2015 version that shows you all your data. The most important piece of data for you is this one right here. So this is our periodic table, and also on the bottom left we also have our solubility table. Now, the way to use the solubility table is depending on the combination of ions. Certain combinations of ions are insoluble and certain combinations are soluble. So on the first table, these are all the different types of chlorides, bromides, iodides, nitrates, ethanoids, so all your different types of anions that are soluble. And then in the second part is the important part, that here are the exceptions. So all chlorides are like sodium chloride, they're soluble. We know this salt, you can dissolve that in water. However, if there's silver ions in solution, they will like to link with chloride ions, you get silver chloride. And that is like, it's a bit of a white precipitate. And the same with lead. Lead tends to come out of solution, as you can see here. Lead chloride, lead bromide. With sulfates, you have strontium sulfate, barium sulfate, lead sulfate that are completely insoluble. And you've got calcium sulfate and silver sulfate that are slightly soluble. So notice that soluble means that more than 0.1 moles will dissolve for every liter of solvent, which is usually water. A slightly soluble is between 0.01 and 0.1 of a mole, and insoluble meaning less than 0.1 of a mole will dissolve per liter. So insoluble doesn't necessarily mean that there won't be any ions in solution. There will be. However, there'll be a very, 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 very small fraction of those ions, so there'll be a very, very small fraction of silver and chlorine ions in solution than the solid silver chloride. So they won't all be there. However, the vast majority of those ions will form silver chloride. So if we use that table, the second table, here we go. These are all the insoluble anions. So you have most hydroxides, most carbonates, most phosphates, and most sulfides that are insoluble, with the exceptions of these. So any sodium salts, it doesn't matter, sodium ions will always be soluble in solution. You can pretty much be sure of that. And same with potassium, and ammonia tends to be quite soluble also. So let's go back to our equation. Sodium hydroxide and magnesium chloride. So we can see here that sodium chloride, so all sodium hydroxide, so all most hydroxides are insoluble except for sodium hydroxide. So we know that's soluble. We have magnesium chloride. We know that all chlorides are soluble. However, we have these different ions in solution. So in solution, we actually have sodium plus ions and OH negative ions, but we also have magnesium 2 plus ions and chlorine negative. So let me write that in. We have sodium plus ions, and we have hydroxide ions in solution. We also have magnesium ions, so they have a charge of 2 plus, and chlorine ions. Now if you have a look, because we have those hydroxides, then what a double displacement reaction is literally they're going to swap. The cations and anions are going to swap partners, and usually there's going to be a reaction. In this particular type of reaction, we have a precipitation reaction. So we know that most hydroxides are going to be insoluble, so a combination of these two will give us our precipitate. So if we do the whole reaction, so let's first come out with the solid, the precipitate. So we're going to have magnesium, and because hydroxides are only 1 negative, magnesiums are 2 plus, we're going to need 2 of those, and they're going to be solid. And we also have those other ions in solution. Now they don't really do anything, okay, because sodium chloride is completely soluble in solution. I'm going to talk about this particular pair in a second. There's one thing missing from this particular equation, and that is balancing. We need to make sure that they are actually balanced. On the left hand side we have OH, so we have one set of OH. However, on the right hand side we have 2 sets. So straight away we need to double our hydroxides. So now our hydroxides are balanced. We have 2 hydroxides on the left hand side, 2 hydroxides on the right hand side. However, on the left hand side we have 2 sodiums, and on the right hand side we only have 1, so we need to double that. That becomes 2, and now it's balanced because we have 2 chlorines on that as a product, we have 2 chlorines as a reactant, and now that is balanced. However, this is just a double displacement reaction. This doesn't actually show us what the actual precipitation reaction is. So to actually break it down, our precipitation reaction, okay, PPT reaction, will actually only involve the ions that actually take part, that actually produce the solid, and our solid is magnesium hydroxide. So with magnesium hydroxide, the actual precipitation reaction will be just the magnesium ions, and they are dissolved in solution. Now that's very important, don't forget about that part. And they like to link up with hydroxide ions, that's also very important, and you produce magnesium hydroxide as a solid. And of course, something that we are missing, we need to also balance, because on the right hand side we have 2 hydroxides, so we need to balance it. So here we go, we have our balanced precipitation reaction. Now following on, let's do a little bit of stoichiometry. With 20 grams of sodium hydroxide, how much precipitate will you actually produce? Now this video is getting a little bit long, so I might actually make a new video on how we'll actually figure out how much precipitate we'll actually produce.